Hello? Oh. Hello, ladies and gentlemen. Thank you for joining. My name is Christian Betzing, and I would like to talk about our product, MagnaDense, and why it might make a difference for your project. We are also here at stands B134. So if you have any questions after the presentation, please come visit us. I will start talking a bit about the history of our company, about our products, and about the challenges of the industry and how we might face them with our product. Afterwards, my colleague Mark Moriarty will talk about how we already helped in some projects with our products. So to start, we have to travel to the north of Europe, to Sweden. And when we are in Sweden, we have to go even farther to the north, and there we'll find the company LKAB. LKAB is a Swedish-owned company, which are one of the world's biggest iron ore mining companies and Europe's biggest. Also one of the leading companies for producing refined iron ore products for the steel industry. They're currently, for example, developing sponge iron to use for emission-free steel making. LKAB has different subsidiaries, and one of them is LKAB Minerals, which we are representing here. LKAB Minerals is has also offices worldwide. So feel free to contact us. We have on many parts of the world contacts in person available. Our company is taking the iron ore from our mother company LKAB together with other minerals, and we are refining these minerals and selling them to a broad range of industries, from civil engineering to water treatment to plastics. I would like to talk today about our product MagnaDense, which is magnetite, so an iron oxide, which our mother company is mining. 27 million tons per year, and we are refining a part of it and selling it further to other industries. For the civil engineering industry and for radiation protection, it is called MagnaDense. It is very pure iron oxide with a specific density of up to 5.2 tons per cubic meters. It is also chemically inert, non-hazardous, and durable. So the industry has few challenges we know of, and we try to help you face them in the industry. We can guarantee you, for example, a very good supply chain and resource availability. I already talked about the 27 million tons we mine every year, so there's no problem in getting the material to your place. Also, being an international company for providing iron ore worldwide, we have a logistics available everywhere. The quality is controlled in the mines and on every step up until the customer. So also the quality, which is of course very important in the nuclear industry, is always controlled. We help you with everything else, and also the products are also regulated and certified for everything important in the civil engineering industry and nuclear industry. So what benefits does MagnaDense has? MagnaDense is, which is the most important, it's certified to be used as an aggregate, and it is also certified to be used for radiation protection. It is compatible with standard ready-mix equipment and precasting. So the main usage is you can substitute the normal aggregate you use in concrete with our products. Then the products or the concrete at the end has a far higher density because you don't have your normal sand, etc., with a density of 2.6, but you have particles up to a density 4.7 to 5.2. And in the end, you can have a concrete fully made out of MagnaDense particles with a density of 4.0 tons per cubic meters. So in the end, you can make far thinner walls for radiation shielding. If you have a bunker for medical reasons, for research centers, or for nuclear power plants, you can reduce the wall thickness where it's needed. Also, due to the high density MagnaDense has, you can also, or it can also reduce the heat of hydration the concrete is producing while it is stabilizing. So it is less prone for cracking, which is also really important for the nuclear industry. It is proven for decommissioning and medical applications. So we also have the experience here. To tell you more about the proven uses and projects we have already done, my colleague Mark Moriarty will tell you more about the real-life cases we have already done.
Hello, thank you very much, Christian. Good afternoon, everybody. Bonjour tout le monde. So yeah, I'm going to talk about two case studies that LKAB have done, two projects. One of them is probably the first decommissioning project we did, certainly in the UK. This goes back some 40 years when the initial decommissioning project took place. So many of you will be familiar with the Windscale gas-cooled reactor. It's located at what is now known as Sellafield in the UK in Cumbria. So the reactor itself initially was a development and research project. It was one of the first reactors in the UK, and the idea, it was designed to develop a new generation of reactors to power the UK country. So construction began in the 1950s. The reactor achieved criticality in 1962, and that run for nearly 20 years when decommissioning began in 1981. So, as the name suggests, it was a gas-cooled reactor with an output of around about 32 megawatts of electricity. So it says there it was one of the first UK facilities to undergo decommissioning, and it was the first nuclear power plant in the UK to be decommissioned. And as it mentions there, it was used as a development tool. And I think its legacy actually is the fact that the current decommissioning programme in the UK stems from a lot that was learnt from decommissioning the Windscale reactor. So just a bit more about the project. So the Windscale reactor was the first of a family of 14 reactors that were built in the UK. It was obviously designed, as most nuclear power plants are, to generate cheaper and more efficient electricity for the country. And at the end of its active life, it became the first UK decommissioning project. I would say that it became the first nuclear power plant decommissioning project. So the actual decommissioning itself began in 1997 and ran for a period of about 12 years. So in terms of LKAB's involvement, we supplied heavy aggregate to produce the concrete boxes that were designed to contain intermediate level waste primarily. So we work closely with concrete producers and designers of the box to make sure that the concrete was fit for purpose. So the project itself required around about 110 intermediate level waste containers. These were 6 meter cubed concrete boxes, by the way, and around about 75 low level waste containers. And there was also some concrete overpacks which were designed for transporting some of these concrete boxes to different locations. So the concrete used, which contained MagnaDense, had a target density of 3.9 tons per cubic metre, which is at the upper end of what's achievable with MagnaDense aggregate alone. We are able to achieve higher densities in concrete, but then you need to start looking at the inclusion of iron and other high density materials. So not only these were the boxes themselves made of high density magnetite concrete, but they were also filled, the intermediate level waste was encapsulated with a high density grout, which is a hematite, Fe2O3 oxide, which was also supplied from LKAB, again from Sweden. So in total, the project required 4,000 tons of magnetite and hematite, and the package volume was around about 2,500 cubic meters. So there's a design there of one of the initial Wagger boxes, as they became to be known. So that's a 3.9 density concrete. There's a mild steel reinforcement around the top and the bottom of the box. And there's also some lifting fixing so that the boxes could be lifted and stacked. So the concrete was designed to withstand a certain impact energy, and also obviously to be able to be stacked 2 or 3 boxes high. So it's just an overview of the project itself. The project owner at the time was British Nuclear Fuels, which I think was a division of UK AEA, the UK Atomic Energy Association. The operations contractor to UK AEA at the time was Magnox. I think they've just undergone a rename, but they are still very much active in the UK decommissioning sector. The concrete producers for the box was Tarmac. Says there that the project was completed in December 2015. So remember that decommissioning actually started in 1997. You can see it was quite a lengthy process. And then also, on top of the boxes themselves, LKAB were involved in the storage facility at Sellafield, which was designed to house these boxes, and that involved a total concrete of around about 1,000 cubic meters, requiring 4,000 tons of MagnaDense. And again, the concrete density there you can see was 3.8 tons per cubic meter. So I think the interesting thing with the Wagger boxes is that Magnox are still operating today. We have around about a dozen sites in the UK which are currently being decommissioned by Magnox. And the box design that was originally produced is more or less being used today for decommissioning. There's a company in Sheffield called Amber Precast that are making these boxes for Magnox. They've made some improvements to the boxes, but essentially they are the same boxes that were originally designed and used to decommission the site at Sellafield. So you can see that the current programme is worth £4 billion. So it's still very much active. There's a number of UK sites that still require decommissioning, and you can see there that we're looking at, even now, 100-year plus to remedy or clear those sites. So that we mentioned Sellafield there, and the Wagger decommissioning was probably the very first project in the UK or major project for radiation shielding. And now we come right up to date. So LKAB as a company are supplying the European Spatial Source Project, ESS, with magnetite for radiation shielding purposes. Now, you probably know about this project, but just in case you don't, this is a very advanced research facility that's been constructed in the north of Sweden. It involves a pulse proton source designed for research purposes, and it will be the world's most powerful neutron beam once it's up and running. So you can see it's a European-wide project. There's 13 member countries, including Sweden and Denmark. I know in the UK that we've been involved in producing hot cell components. So although it's a proton beam, once the beam strikes the target to generate the the particles for research, a lot of the components become radioactive, and they need to, at the end of their service life, be stored. So there's very, very high levels of radiation involved with the project. So as I say, we're currently supplying this at the moment. There has been some delays with the project, obviously COVID and some technical challenges. So you can see there's a bit of a review of the project. It's one of the largest science and technology infrastructure projects built today. And it will house the world's most powerful linear proton beam accelerator ever built. And the whole purpose of the project is to research neutron and particles. But so this technology will generate both neutron and gamma radiation, which is important because obviously, you know, we are a supplier of high density material, and high density material is more effective at shielding gamma radiation. So for this particular project for ESS, it requires two layers. The first layer is a layer designed to slow down the protons, which will be a low density material, and then the high density material behind will capture the slowed particles. I mean, it's interesting to note that concrete itself obviously is a product of many hydration chemicals. So, there is a high percentage of water contained in concrete, which will help to prevent the passage of neutrons. So the key points for this: the main developer was Skanska. So the concrete was supplied to AB Seisden. So at the moment, I mean, it's saying 14,000 tons. I know that the figure supplied is in excess of that, and it's ongoing at the moment because there are other areas that are still in construction that are about to use high-density concrete. Okay, so as Christian mentioned, we are on stand B134. We have been involved in a number of nuclear and radiation shielding projects, not just the two that we've covered there quite briefly. So if you have any interest in radiation shielding, whether it's for a nuclear new build, if it's for decommissioning, yeah, we'd certainly like to talk to you today. Thank you very much.